Okay, guys, this is exam 4, question number 4. Let A be equal to the set containing the numbers 0, 1, 2, 3, and 9, and define an equivalence relation on A as E is equal to the set of ordered pairs. What are the distinct equivalence classes? So because there's not a lot of elements of A, and I find a directed graph um, helps me visualize what's going on, I'm going to start by drawing a directed graph. So we have 0, we have 1, we have 2, we have 3, and we have 9. Okay, and so now I'm just going to start drawing out these ordered pairs. 0 relates to 0. 0 relates to 9. Actually, let me do it this way. Okay. 1 relates to 1. 1 relates to 3. 2 relates to 2. 3 relates to 1. 3 relates to 3. 9 relates to 0. And 9 relates to 9. Okay, so that's all of our ordered pairs. So I'm going to start by listing out all the elements in A. We're looking for the distinct equivalence classes. The first thing I'm going to find is all the equivalence classes, and then we're going to summarize them into distinct classes. So I'm going to start by putting down the notation for the equivalence classes is you put the number inside this bracket. So we'll start with 0. And I'm just going through every element in A. 0, 1, 2, 3, and 9. And an important note here, this is sort of our Y, the second part of our order pair. In other words, this is where this is where the order pair ends up. Okay? So I'll give you an example. 0 ends at 0. So 0 is one of them. So don't forget the set notation. And also 9 ends at 0. And just a quick little tip, I would recommend doing them in ascending order. So even if you come across a number that's, like high first, I would just reorder them in ascending order. It makes it sort of very easy to determine what equivalence classes are the same. So 1 ends at 1. 3 ends at 1. 2, the only element that ends at 2, or the only order pair that ends at 2 starts at 2. 3. We have 1 going to 3, and then 3 going to itself, so that's 1 comma 3. And finally 9, 0 is going to 9, and then 9 is going to itself. So I want you to notice that 0 is the same as 9, and 1 is the same as 3. And then 2 is sort of all by itself. So now I'm going to finally answer the question with distinct equivalence classes. We have 0 is equal to 9 is equal to the set containing 0 and 9. We have 1 is equal to 3, which is equal to the set containing 1 and 3. And finally 2, there's no equivalent, it's all by itself, so that's just the set containing the number 2. And that is the answer.